Let's try this next one. Okay, so I know my midline is at 3, so 1, 2, 3. Here is my midline at 3. Why don't you go ahead and try to graph this thing first? You might want to draw on your unit circle to help you. Boom, boom, we have 0 / 2 pi. We have pi over 2. We have pi. And we have 3/2 pi. And now we're talking about sine, which is distance from the ground. Okay? So let's see here, and let me put in my spots. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8. Pi, 1, 2, 3, 4, 5, 6, 7, 8. There's 2 pi, 1, 2, 3, 4. There's 3/2 pi, 1, 2, 3, 4. There's pi over 2. So I have all the spaces that I need. Okay. Now, this is a sine, right? Has an amplitude of 2.5. So from 3, I'd go up 1, 2, 1, 2.5. So that's going to be my highest point. 1, 2.5. That's going to be my lowest point. So everything goes between those 2 points. So it's a lot of stuff to think about here. Okay? So now, let's find out the sine of 0. So at the sine of 0, I'm over here. And now we're talking about distance from the ground. Well, I'm on the ground. I'm at the midline. I have no height off of the ground. So at 0, my sine is on the ground or at the midline. The midline represents the ground. Right on it. Boom. Okay? Now I'm up here at pi over 2. My distance from the ground. Now I'm at my highest position from the ground. If the ground is here, I'm as far as I can be from the ground. I have a height of 1. Or in this case, at pi over 2, I have a height of whatever this is. What is this? 2.5. So this is 4, 5. So this is 5.5. So I'd be at 5.5 here. Okay? Now I'm going to pi. At pi, once again, if we're talking about what is this dot's distance from the ground is here. It's on the ground. So at pi, I'm back onto the midline. Boom. Now I go to my next angle here, 3/2 pi. And again, I'm looking. So now I'm here. How far am I on the ground? I'm now below the ground. I'm as far as I can get below the ground. So at 3/2 pi, I'm as far as I can get below the midline, which is right here, which is at 0.5, really, right? And then finally, I get back to 2 pi, which is the same as 0, which is going to be back onto the midline. So my sine curve just went, woof. Okay? So you're going to get more practice with these in class. I tried to explain my thinking as much as I could, and that's what I have. All right. Last thing. Finding the b value in trig equations. You want to write this down in a trig equation. Okay? Remember that as we know y equals a. We know how to find the a value times either sine or cosine b minus h plus k. We know what the h value is. We know what the k value is. But how do I find the b value? That's what we got to figure out. And remember, the b value changes the period of the function. It makes the function happen either in a faster amount of time or a slower amount of time. And so I wrote down here, so to find the b value, what you're going to do is you're going to take the regular period, which is always the same. The full period is 2 pi, and you're going to divide it by the new period. That will give you your b value. So I'm not going to get totally into why, but hopefully this helps you see it. Let's look at this regular sized sine curve that has a period of 2 pi. Now I'm going to compare it to a sine curve that has a period of pi. What does that mean? That means this thing happens faster. It happens twice as fast. What took 2 pi over here is now only taking 1 pi over here. It's doing it twice as fast, right? 2 times as fast, right? Because in the same amount of space, I could actually do 2 on this one if I wanted to, because it's going twice as fast. And what took me 1 period to do 1 full rotation here, I could actually do 2 and 2 pi here because it's going twice as fast. Hopefully that's clear to you. But if I take this period, or a regular period is 2 pi, and I put it over this new period of pi, this is going to give me the b value, because what happens? Well, pi cancels out, and b ends up equaling 2, which means it went twice as fast. My b value is 2. When I take it and multiply it by 2, I get a shorter period because the circle is moving faster. Okay? But I can do this for anything. Let's say I'm not even going to do that. I'm going to erase this. You won't, but I'm going to erase it. Let's say we had this new thing. Give me 1 second. We got the kids screaming outside, so hopefully you don't hear too much of that. But if you do, sorry, it's nothing I can do about it. So let's say we have this same in comparison to this sine wave, but now instead of 2 pi as my period, let's say we're going in time. So this is by angle. Let's say we were doing a same sine wave, but in terms of time. Let's say it was time. So from 0 seconds to, let's say, 36 seconds. I can still do the same thing, and I can figure out my b value, right? I can take the regular period, which is 24, which is 2 pi, put it over the new period, which is 36 seconds. And remember, this is 2 pi radians, which is 36 seconds, and that's going to give me my new b value. So 2 pi over 36, which I could do, equals b. Or if I wanted to, I could say, and remember, pi is just a number. So this is really just 2 times 3.14. So this is really approximately 6.28 divided by 36, because pi is basically 3.14. So I could take 6.28 and divide it by 36 if I wanted to. Let's see. Pull my calculator up. 6.28 divided by 36 equals, my b value would be 0.174 repeating. So this would be the b value. But we're not going to make you do the b value like this. Actually, so you can see what's happening, we're just going to let you leave your b value as 2 pi over 36. This is really the answer we want, because you can see that 2 pi is now happening in some different time frame, whether it's happening in pi time frame or 36 seconds or whatever it may be. All right? So we're going to work on all of this in class. We're putting everything together next class, and then you'll have your kind of final opportunity to show what you understand about this on Thursday or Friday. All right, guys. Thanks.